Yes, it is acceptable not to have all the disconnects for a building in one location. The National Electrical Code, specifically Section 230.2, permits multiple services to a single structure. Each of these services, as per Section 230.71, can have up to 6 disconnects. However, it is crucial that these disconnects are grouped together for each individual service, also stated in Section 230.71. In a scenario like a large apartment complex, it's possible to have multiple services, such as 2 meter stacks and a house load, all supplied from the same utility transformer. Even if the meter stacks are physically separated, located at opposite ends of the building, the configuration can still comply with the National Electrical Code. The disconnects for the house load can be situated in one location, while the disconnects for each meter stack can be located at their respective stack. This arrangement is permissible because the disconnects for each specific service are grouped together. The National Electrical Code does not mandate that all the disconnects for an entire building be consolidated into a single location. To elaborate further, it is important to understand what constitutes a service. A service, as defined by the National Electrical Code, is a conductors and equipment used for delivering electrical power from the serving utility to the wiring system of the premises being served. This includes the service entrance conductors, the service disconnect, and the overcurrent protection devices. When multiple services are installed in a building, each service must be treated as a separate and independent electrical system. Each service must have its own set of disconnects, and these disconnects must be grouped together. The purpose of grouping the disconnects is to allow the fire department or other emergency personnel to quickly and easily disconnect all power to a particular service in the event of a fire or other emergency. The 6 disconnect rule, as it is commonly known, is found in Section 230.71 of the National Electrical Code. This rule states that each service can have up to 6 disconnects. These disconnects can be either circuit breakers or switches, and they must be grouped together in a readily accessible location. The 6 disconnect rule is intended to provide flexibility in the design and installation of electrical services. It allows the electrical designer to choose the number and type of disconnects that are best suited for the particular application. However, it is important to note that the 6 disconnect rule does not allow unlimited disconnects. The total number of disconnects for each service is limited to 6. In the example of the apartment complex with 2 meter stacks and the house load, each of these 3 services can have up to 6 disconnects. The disconnects for the house load can be located in one location, such as the main electrical panel. The disconnects for each meter stack can be located at the meter stack itself. This arrangement is acceptable because the disconnects for each service are grouped together. There is no requirement in the National Electrical Code that all the disconnects to a building must be in one location. This is because each service is treated as a separate and independent electrical system. It is also important to note that the disconnects for each service must be readily accessible. This means that they must be located in a place where they can be easily reached in the event of an emergency. The disconnects must also be clearly labeled so that it is easy to identify which service they control. In addition to the 6 disconnect rule, the National Electrical Code also contains other requirements for service disconnects. For example, Section 230.70 requires that the service disconnect be suitable for the available fault current. This means that the disconnect must be able to safely interrupt the maximum amount of current that could flow in the event of a short circuit or ground fault. Section 230.95 also requires ground fault protection for certain types of services. Ground fault protection is designed to protect people from electrical shock. It works by detecting small ground faults and quickly disconnecting the power. In addition to the requirements in the National Electrical Code, there may also be local requirements for service disconnects. These requirements may vary depending on the jurisdiction. It is important to check with the local electrical inspector to determine the specific requirements for service disconnects in a particular area. To summarize, the National Electrical Code allows multiple services to a single structure. Each service can have up to 6 disconnects, but the disconnects must be grouped together for each individual service. There is no requirement in the National Electrical Code that all the disconnects to a building must be in one location. The disconnects for each service must be readily accessible and clearly labeled. The service disconnect must be suitable for the available fault current, and ground fault protection may be required. It is important to check with the local electrical inspector to determine the specific requirements for service disconnects in a particular area. Understanding these rules and regulations is essential for ensuring the safety and proper functioning of electrical systems in buildings with multiple services. Furthermore, let's delve into some specific sections of the National Electrical Code that are relevant to this discussion. Section 230.2, as mentioned previously, addresses the number of services permitted to a building or other structure. It generally allows only one service, but it also outlines several exceptions where multiple services are permitted. These exceptions include situations where the capacity requirements exceed the limitations of a single service, where different voltage or frequency requirements exist, or where specific circumstances make it impractical or unsafe to supply the entire load from a single service. When multiple services are installed under these exceptions, each service must meet all applicable requirements of Article 230, including the requirements for disconnects. Section 230.71, which covers the maximum number of disconnects, is another key section. As previously stated, it allows up to 6 switches or 6 circuit breakers to serve as the service disconnecting means. The intent of this rule is to provide a degree of flexibility while still ensuring that all power to the building can be quickly and easily disconnected in an emergency. The requirement that the disconnects be grouped together is intended to facilitate this quick and easy disconnection. Section 230.72 addresses the grouping of disconnects. It requires that the 2 to 6 service disconnecting means permitted in Section 230.71 be grouped, and each service disconnecting means shall be marked to indicate the load served. Section 230.95 provides detailed requirements for ground fault protection of equipment. This section requires ground fault protection for each service disconnecting means rated 1000 amps or more and operating at more than 150 volts to ground, but not exceeding 1000 volts phase to phase. The purpose of ground fault protection is to reduce the likelihood of electrical shock and fire hazards caused by ground faults. It's important to recognize that the National Electrical Code is a comprehensive document, and these sections are just a small part of the overall code. Electrical professionals must have a thorough understanding of the entire code in order to ensure that electrical systems are designed and installed safely and in compliance with all applicable requirements. To provide additional context, consider the practical implications of these rules in the apartment complex scenario. The 2-meter stacks, each serving a portion of the apartments, represent separate services. The house load, which might include common area lighting, elevators, or other building-wide systems, represents another separate service. Each of these services is fed from the same utility transformer, but they are treated as distinct electrical systems within the building. The disconnects for the house load are located in a central location, such as the main electrical room. This allows building maintenance personnel to easily disconnect power to the house load for maintenance or in an emergency. The disconnects for each meter stack are located at the meter stack itself. This allows utility personnel to disconnect power to a particular meter stack for maintenance or in the event of a non-payment issue. The fact that the meter stacks are located at opposite ends of the building does not violate the National Electrical Code, as long as the disconnects for each service are grouped together and readily accessible. In summary, the National Electrical Code provides a framework for safely and effectively distributing electrical power in buildings with multiple services. The rules regarding the number and grouping of disconnects are designed to ensure that power can be quickly and easily disconnected in an emergency, while also providing flexibility in the design and installation of electrical systems. It is essential for electrical professionals to have a thorough understanding of these rules in order to ensure that electrical systems are installed in compliance with all applicable requirements. Let's consider other aspects related to electrical services and disconnects within a building. First, it's essential to define what constitutes a service in the context of the National Electrical Code. A service is the electrical supply from the utility company to the building or structure. It includes the service conductors, metering equipment, and the service disconnect. The service disconnect is the main switch or circuit breaker that can shut off all power to the building. In the case of multiple services, each service has its own set of service conductors, metering equipment, and service disconnects. The location of the service disconnects is crucial for safety and accessibility. The National Electrical Code requires that service disconnects be readily accessible, meaning they must be located in a place where they can be easily reached in an emergency. They must also be clearly labeled to indicate the area or equipment they serve. In an apartment complex with multiple services, the service disconnects for each apartment unit are typically located near the meter for the unit. This allows utility workers and emergency personnel to easily disconnect power to a specific apartment if needed. The service disconnect for the house load, which serves common areas and equipment, is usually located in a central electrical room. This allows building maintenance staff to easily disconnect power to the entire building if necessary. The type of service disconnect used depends on the size and voltage of the electrical service. For smaller services, a simple switch or circuit breaker may be sufficient. For larger services, more sophisticated equipment, such as fuse disconnect switches or power circuit breakers, may be required. The National Electrical Code also specifies requirements for the overcurrent protection of service conductors. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect the service conductors from overload and short circuits. The size and type of overcurrent protection device must be carefully selected to match the ampacity of the service conductors. In addition to the National Electrical Code requirements, local building codes and utility company regulations may also affect the design and installation of electrical services. It is important to consult with local authorities and the utility company to ensure that all applicable requirements are met. Another factor to consider is the grounding and bonding of electrical services. Grounding and bonding are essential for electrical safety, as they provide a path for fault current to flow back to the source, tripping the overcurrent protection device and energizing the circuit. The National Electrical Code specifies detailed requirements for grounding and bonding of electrical services, including the size and type of grounding conductors, the location of grounding electrodes, and the bonding of metallic enclosures. The grounding and bonding system must be properly installed and maintained to ensure electrical safety. In summary, the design and installation of electrical services is a complex process that involves careful consideration of the National Electrical Code, local building codes, and utility company regulations. Multiple services are permitted in certain situations, but each service must meet all applicable requirements, including the requirements for service disconnects, overcurrent protection, grounding, and bonding. Proper planning, design, and installation are essential to ensure the safety and reliability of electrical services. Considering the specific case of an apartment complex, let's explore further nuances. With 2-meter stacks feeding different sections and a house load supplying common utilities, the distribution of power becomes intricate. Each meter stack would likely serve multiple individual apartment units, with each unit having its own breaker panel for distributing power within the apartment. The house load, on the other hand, might power lighting in hallways, stairwells, and parking areas, as well as operate elevators, water pumps, and HVAC systems for the building. It's important to ensure that the house load is properly sized to handle the total demand of all these systems, with sufficient capacity for future expansion. The selection and coordination of overcurrent protection devices is also critical. Service disconnects must be sized to protect the service conductors from overload, and the branch circuit breakers within each apartment unit must be sized to protect the individual circuits within the apartment. Coordination of these devices ensures that a fault on the branch circuit will trip the branch circuit breaker without tripping the service disconnect and shutting down power to the entire building. Load calculations are also essential. The National Electrical Code provides detailed methods for calculating the electrical load of a building, taking into account the size and type of appliances, lighting, and equipment. These calculations are used to determine the required size of the service conductors, the service disconnect, and the overcurrent protection devices. Accurate load calculations are essential to ensure that the electrical system is adequate for the building's needs without being oversized and wasting energy. Regular maintenance and inspection of electrical services are also important. Over time, electrical equipment could degrade due to age, corrosion, and other factors. Regular maintenance, such as tightening connections, cleaning equipment, and testing overcurrent protection devices, can help to prevent failures and extend the life of the equipment. Regular inspections can identify potential problems before they become serious, allowing for timely repairs. Properly designed and maintained electrical services are essential for the safety and comfort of apartment residents. By following the requirements of the National Electrical Code and other applicable regulations, building owners and managers can ensure that the electrical system is reliable, efficient, and safe. Keep in mind that electrical work can be dangerous and should only be performed by qualified electricians who are familiar with the National Electrical Code and other applicable regulations. Incorrectly installed or maintained electrical systems can pose a serious risk of electrical shock, fire, and other hazards. Let's delve even deeper into the technical aspects of service disconnects and their application in multi-unit dwellings like apartment complexes. When dealing with multiple services originating from the same utility transformer, careful consideration must be given to fault current coordination and selective coordination. Fault current is the amount of current that flows during a short circuit or ground fault condition. The available fault current at the service entrance depends on the utility transformer's impedance and the length and size of the service conductors. It's crucial to ensure that the service disconnects and overcurrent protection devices have a sufficient interrupting rating to safely interrupt the available fault current. If the interrupting rating is too low, the device may fail to clear the fault, leading to equipment damage, fire, or even explosion. Selective coordination involves designing the overcurrent protection system so that only the device closest to the fault trips, while upstream devices remain closed. This minimizes the extent of the outage and allows other parts of the building to continue operating. In an apartment complex, selective coordination would ensure that a fault within a single apartment unit trips the branch circuit breaker in that unit, without tripping the service disconnect for the entire building. Achieving selective coordination requires careful selection and coordination of overcurrent protection devices, taking into account their time current characteristics and interrupting ratings. It may also involve using current limiting fuses or circuit breakers, which can quickly reduce the magnitude of the fault current and allow downstream devices to trip selectively. Another important consideration is the accessibility of service disconnects for emergency responders. In the event of a fire or other emergency, firefighters need to be able to quickly disconnect power to the building to prevent electrical hazards. The service disconnect should be clearly marked and located in a readily accessible location, such as near the main entrance or in a dedicated electrical room. It's also helpful to provide a single-line diagram of the electrical system, showing the location of all service disconnects and their associated loads. This can help emergency responders quickly identify the correct disconnects to operate. In addition to the National Electrical Code requirements, some jurisdictions may have additional requirements for service disconnects in multi-unit dwellings. For example, some cities require that all service disconnects be grouped together in a single location, regardless of whether they serve different services. This simplifies the process of disconnecting power in an emergency, but it may also increase the cost and complexity of the electrical installation. Other jurisdictions may require that all service disconnects be remotely operable, allowing them to be disconnected from a central location. This can be useful in situations where access to the building is restricted, or where it's necessary to disconnect power to the entire building quickly. In summary, service disconnects are a critical component of the electrical system in multi-unit dwellings. They provide a means of safely disconnecting power to the building in an emergency, and they help to protect the electrical system from overload and short circuits. Proper design, installation, and maintenance of service disconnects are essential to ensure the safety and reliability of the electrical system. Remember to consult with qualified electrical professionals to ensure compliance with all applicable codes and regulations.